Okay, we're going to find limits of piecewise functions. Piecewise functions are functions defined in pieces. We have many multiple rules in one function, and we have to choose the function appropriately. Right. I'm going to organize this information on a number line. So we can see that 1, I'm going to mark 1 here, so that for x less than 1, this is the area x less than 1. And the rule is x squared, and for x greater than 1 the rule is 2x. Right, so the question here is find left limit and right limit. So limit x going to 1 minus f of x, and limit x going to 1 plus f of x. This is what we need to find. So I've just organized the information here. So the left limit, this will be the left limit, and this is going to be the right limit. So in the left limit we have x going towards 1 minus. In the left of 1, the rule is x squared. So f of x is actually x squared. So we want to find, as x approaches 1 from the left side, what happens to x squared. So we can just plug in here, use the plug-in technique, which is much faster than the table method. So we're going to plug in x equal to 1 in the rule. So this will become equal to 1 squared, which is 1. So same way we want to find the right limit. So as x approaches 1 plus, we have limit x going to 1 plus. The f of x here is on the right side of 1, the rule is 2x. So we're going to put 2x here. Same way we're going to use plug-in x equal to 1 in the corresponding rule. So 2 times 1, which is 2. So we have the left limit and the right limit are not equal, but they exist. So if the question was find limit x going to 1 f of x, then that limit does not exist. Limit exists only if left and right limits are equal. Another piecewise function example here. We want to find left and right limits at x equal to 0 and x equal to 3. So first we will focus at x equal to 0. Left limit would be limit x. Okay, so sorry, even before that, let's organize this function first on the number line. So we have 0. On one side of 0, the function is on x less than 0. The rule is 2x. And then we have 3. From 0 to 3, the rule is x squared. On x greater than 3, this is the region, and the rule is x plus 3. So this organization will help us decide which rule to use. So we're going to identify what is the limit at 0 and what is the limit at x equal to 3. So first let's focus on the 0. The left limit, limit x goes to 0 minus f of x, which means x approaches 0 from the left side. On the left side of 0, the rule is 2x. So we're going to replace f of x by 2x. X goes to 0 minus. And use the plug-in technique. We're going to plug in 0 for x, and then 2 times 0, 0. So limit x goes to 0 plus f of x, which is the right limit at 0. This becomes limit x goes to 0 plus. The right limit is, the rule is x squared. Again, plug in, it'll become 0 squared, which is 0. So actually left limit and right limit are equal. So limit at 0, x goes to 0, f of x is 0. So if the left limit and the right limit exist and are equal, then it is the limit at 0. Right, so this is the left limit. This is the right limit. Okay, so now let's focus on the x equal to 3. limit x going to 3 minus, this is the left limit, on the left of 3 the rule is x squared, x goes to 3, and then plug in 3, it will become 9. And then we have the right limit at 3. Limit x goes to 3 plus of the function, and where the rule is on the right side of 3 is x plus 3. We're going to plug in 3 here, which will become 3 plus 3, which is 6. So the left limit and the right limit exist but are not equal. So the limit x goes to 3, f of x does not exist. They exist only if both the limits exist and are equal. So here is an example of okay, so is the function continuous? Is f of x continuous at x equal to 1? And we want to justify with limits. Let me just write the definition of continuity. Definition is f is continuous at x equal to 1 if left limit at 1 equal to right limit equal to f of 1. So the left limit equal to right limit should be equal to the function value at 1. And maybe I will make this in less equality. So we're going to find the left limit and find the right limit and the function value, and then see if all three are equal. So even if one equality fails, the function is not continuous. So we're going to do the left limit. So limit x goes to 1 minus of f of x. Let's draw this horizontally. We have 1. On the left side of 1, the rule is 2 plus x. On the right side of 1, the rule is 2 minus x. Okay. So x goes to 1 minus f of x is actually limit x goes to 1, and then 2 plus x is the rule. We're going to plug in 1, plug in, so 2 plus 1, which is 3. Same way, right limit would be limit x goes to 1 plus f of x is equal to limit x goes to 1. On the right side of 1, the rule is 2 minus x. We're going to plug in again. So the plug-in technique works as long as if you plug in and it is undefined. If you plug in and it is not undefined, it will work. 2 minus 1, which is 1. So the left limit exists and the right limit exists, but both the limits are not equal. And so let's try to find f of 1. F of 1 is, there is an equality here. So f of 1 is going to be 2 plus 1, which is 3. So the left limit not equal to right limit, and so function is not continuous. So f of x is not continuous at x equal to 1. So the graph will have a break at 1. The graph has break at x equal to 1. All right.